Of course, the carbon in you and I, and the air we breathe, is older than the Earth itself. But we can start this story of carbon, the crude story, in the fiery mouth of an active volcano much like this one, on a very different looking planet, a long, long time ago. Back in the mid-Jurassic, the Earth was a dinosaur-inhabited world on the move. The continents, once joined together, were now breaking up, and the sustained volcanism pumped massive amounts of carbon into the atmosphere. Enter our central character, a single atom of carbon. It's been pumped out as a carbon dioxide molecule, joined at the hip to two oxygen atoms. It may be just one in a swarm of countless zillions, but it's as good a guide as any to take us through this oily adventure. As a gas, carbon dioxide helps set the global thermostat in the comfortable range. Too little carbon dioxide in the atmosphere and the entire planet will freeze. Too much and it will cook all over. And the Jurassic Earth is cooking, called the Tethys. There were plenty of clouds, but no great ice caps at the poles.
As far as we know, there was no substantial ice on the planet, so it would have been a warm, what we call a greenhouse world with elevated levels of carbon dioxide.
It was into this greenhouse world that our carbon atom had been released. Now it was one of the many CO2 molecules helping to keep the climate of the dinosaurs hotter than any other period in the planet's history. For perhaps 100 years, it swirled through the landscape, over oceans and deserts, mountains and lakes. Eventually, it drifted into a primeval Jurassic forest. It spent a season inside the leaf of a ginkgo tree, and another 50 years in the body of the dinosaur that ate it. It passed from plant eater to meat eater before being exhaled back into the atmosphere, once again as carbon dioxide. Our molecule drifts on, and finally is swept out over the ancient Tethys Ocean. One day in the future, this warm equatorial seascape will become the oil-rich deserts of the Middle East. But now, the sea is rising, and so are the temperatures. Both the atmosphere and the oceans are loaded with CO2. Our molecule slips into the sea to become food for a phytoplankton cell. Trillions of these tiny plants swarm near the surface, all soaking up the sun and sucking in CO2. Inside this cell, our carbon dioxide molecule is transformed into an energy-rich sugar via the flash of a prehistoric sunbeam. As a means of capturing solar energy and storing it for later use, photosynthesis is brilliant. The cell divides, and then divides again. Sunlight and carbon dioxide are being harvested and squirreled away into organic cell walls and fatty carbohydrate molecules, The whole Tethys Ocean is blooming with phytoplankton. Jump forwards to our modern world. The individual algal cells in a phytoplankton bloom may be microscopic, but en masse, you can see them from space. Giant green swirls appear in places where plant food is concentrated by winds, currents or rivers, or trapped by restricted circulation.